20 years ago, Dubai invested a staggering $1.5 billion to construct the Burj Khalifa, which, at an astonishing height of 828 meters, became the world's tallest building in January of that year and has retained that title ever since. However, the construction of the Burj Khalifa was fraught with challenges. The first major hurdle was the foundation. For most buildings, drilling down 20 to 30 meters is enough to reach solid bedrock. However, the site chosen for the Burj Khalifa was in a desert, where the ground consisted of soft sand. Engineers had no choice but to keep drilling, but even after reaching a depth of 140 meters, they still hadn't found a sufficiently solid layer. When it seemed like the problem had no solution, the engineers devised a brilliant plan to drive the piles directly into the sand. Imagine a simple experiment. When you insert a wooden stick into loose sand, it initially goes in easily, but as the depth increases, the resistance grows, eventually making it impossible to push the stick in any further. This is due to the friction between the stick and the surrounding sand. By applying this principle and after repeated experiments and calculations, the engineers concluded that 194 piles, each 50 meters deep, would be needed to support the weight of the Burj Khalifa. Given the softness of the sand, traditional piling machines couldn't be used, so they had to rely on spiral drilling, slowly boring down into the ground. But another problem arose when they encountered underground water, causing the freshly drilled holes to collapse. Fortunately, the experienced engineers quickly injected drilling fluid into the holes, resolving the issue. Afterward, they inserted pipes into the holes, placed pre-welded steel cages inside, and finally filled them with a special concrete mix, completing the foundation work. After 2 long years of construction, the foundation was finally complete. However, the next challenge was how to ensure that the 828-meter-tall Burj Khalifa could withstand winds of up to 200 kilometers per hour. After extensive experimentation and calculations, the engineers opted for a hexagonal core design, drawing inspiration from dam construction to create protective structures around the core. These protective elements not only optimized the use of space, but also added to the building's functionality. The key to the design was the partition walls, which not only divided spaces but also reinforced the overall structure. During sandstorms, these walls helped to dampen the building's sway, ensuring its stability. Additionally, the building includes numerous structural layers and load-bearing columns to enhance stability in high winds. The engineers also cleverly designed the building with an asymmetrical and spiraling shape, effectively dispersing wind forces and preventing structural resonance. Ultimately, the 828-meter-tall Burj Khalifa successfully stands tall in the desert.